In the previous video, we looked at configuring data stores based on NFS version 4.1. In this video, we are going to take a look at configuring an iSCSI storage array. We have a easy to use storage array in place, and I will show you how we create LUNs and iSCSI targets and what it looks like on the other side, on the iSCSI side. We will look at configuring VM kernels for iSCSI using the vSphere web client, and then we will look at multi-pathing with iSCSI. Now, right from the beginning, I actually have set up multi-pathing with iSCSI, so you will see a lot of paths up there, but then I will go through the process I actually went through creating various entities on iSCSI storage array side as well as on the VM kernel side for that to actually work. So with that, let's take a look at our iSCSI storage array and see what we have there, and then we will shift over to the web client. So now I'm in my Synology storage manager, and we're looking at the disk group tab. What I have is a disk group, total capacity of 3.63 terabytes made up of 2 disks, each of 1.82 terabytes. So it's a logical entity. On top of that, I have built a volume which is called volume 1, and it has a total capacity of 3.57, out of which 57 gigabytes has been used because I've used thin provisioning throughout. So first comes the disk group, takes the physical disks and puts them together into a physical disk group, and then the volume, logical volume, is built on top of that. I am not using any kind of a RAID, so this is a JBOD, and it's based on that disk group 1. So on top of this volume, I have iSCSI LUNs and iSCSI targets. Let's look at iSCSI LUNs. So I have LUN 1, LUN 2, LUN packed 1, and LUN packed 10, and that is not mapped to any iSCSI target. Let me remove this LUN because I'd like to show you the actual process of creating a LUN. So it's as easy as this to remove that LUN. So before we go there, it's LUN 1 is mapped to target 1, LUN 2 is mapped to target 2, LUN packed 1, which is of 1 gig capacity, is mapped to target 3. So there are 3 targets, 3 LUNs, 1-to-1 mapping. Let's look at iSCSI target. Target 1, as you can see, has this IQN with a dot name. Target 2 has dot name 1, and target 3 has dot name 2. Target 1 has many different IP connections because they are coming in through 2 NICs, and which have 2 IP addresses. And then on the VMware side, I have 4 NICs which are connected as well. So let's count: 1, 2, 3, 4, 5, 6, 7, 8. So 4 NICs on my host, 2 NICs on my storage array, means there are 8 paths that I can come into that target, and that's exactly what we see. And these are all VM kernel addresses. Okay, same thing for target 2, and target 3 has only 1 because that's the way I have actually configured it at this point in time. Okay, let's look at target 3. Default privileges are read-write. Target 2, we see in terms of masking that there is a certain initiator with this IQN for which there is no access. This is an old ESXi host that I had in place, so currently our default privileges are read-write for our 201 host /16 subnet basically. So we have target 1 there, and that's also connected 8 times simply because 4 NICs on one side, 2 NICs on the other side gives us 8 different paths coming into the targets. Okay, so let's create an iSCSI LUN. And again, I'm showing this to you on my Synology. Very often when we work in the vSphere environment, we are kind of constrained to just being allowed to do vSphere administration, and sometimes we are not really aware of what happens on the storage side. We're just given a LUN. So just want to show you that it's actually relatively easy. Of course, the process differs depending on what vendor it is, but conceptually it's very straightforward. So in this case, I create a LUN. There we go. It's a regular file, no RAID. I'm going to give it a name. It'll be LUN packed 10. I reused that before. It's going to be located on that logical volume. I'm going to use thin provisioning. I could have selected no, have had thick provisioning. The capacity is going to be 10 gigabytes, and I will create a new iSCSI target. I could have mapped it to an existing iSCSI target, but it's just easier for me to think in terms of one LUN to one target. Now again, different storage arrays do this differently, but usually the most basic way to do it is by having one LUN to one target. I click on next. I'm not going to enable any CHAP authentication or mutual CHAP. It simply doesn't make any sense to me in a secure physical data center environment. So I click on next, and we are going to create a new LUN pack 10 of 10 gig capacity, thin provisioned, and a new target 4 will be created, which will have an IQN of .name3, because the names start with .name, .name1, .name2, and .name3 for this Synology device. So I click apply, and it will create my targets as well as my LUN pack 10 has been created. It's target 4, and it's ready to go. So with this, we are going to move now to our web client to see what things look like there on that side for the iSCSI. So we are back in the vSphere web client. I'm looking at my host 0.201, looking at networking, and I'm looking at the separate standard switch that I created that I'm using for iSCSI activities. It's usually a good practice, but in a normal environment you'd probably use the distributed switch, because you would have multiple clusters and so on that you would have in place. So for our purposes, the standard switch is actually sufficient. So let's see what we have here. This switch, as you can see, has 4 physical adapters, so ranging from VMNIC 2, 3, 4, and 5. And these 4 adapters are connected through a switch, and they go out to a storage array that has 2 NICs. So we get a total of 4 multiplied by 2, which is basically 8 paths into our targets. Okay. iSCSI, as you know, uses a VM kernel. So let's see what I have here. I have many VM kernels. So let's look at VMK1. It has an address of 172.20.92.1, and it's in my initial port group. And then I have IP addresses for those kernels that go up from 204 to 203 to 202. So basically from 90.201 through 90.204. Now let's examine the first port group. So we look at this port group, and we click on edit. And the most important one is actually teaming and failover, because there's a certain way in which these physical NICs have to be associated with these VM kernels that are going to be used for iSCSI. And basically what it is that out of the whole switch, I can only use one adapter at a time for iSCSI, and that is what gives me multipathing with iSCSI. So for this port group, iSCSI PG port group, I have one active adapter, VMNIC 5, and all the others have been moved to unused. They cannot be at standby. This is a key feature, and that obviously is done by using the failover order and override. So I'm going to cancel all of this. Let's look at this VM kernel. Let's look at the port group actually, and edit the other port group, and look at the teaming and failover for the VM kernel there. You can see that the active adapter is a different one. In the prior one it was VMNIC 5. Now I'm using VMNIC 2 for this, and VMNIC 5 for this is basically unused. So that's the pattern that must be in place before the software adapter, the iSCSI software adapter, will actually find a VM kernel which is compliant for iSCSI. To be compliant with iSCSI, you need to have that capability of making sure that it is basically connected to only one physical NIC, and that can be verified also in this way. So when I click on this, I'm connected to VMNIC 4 only. When I click on this, I'm connected to VMNIC 3 only. Okay, so that's how this is done. And what I did was, in my case, was to start with the iSCSI port group, and one VM kernel at a time. I kept adding 90.201, 90.202, 90.203 until I ended up with 92.04, and I just kept using one other NIC that has not been used. I create yet another VM kernel, a fifth one, but I only have 4 physical adapters. I could reuse a physical adapter, but that gives me no extra redundancy capability, so it makes absolutely no sense. The process of creating the VM kernel adapters you are all familiar with. This is an advanced course, So I'm making that assumption. It's you basically add your physical kernel adapters, you add your host networking, VM kernel adapter, you hit next, all right, and I'm using a standard switch. I use my vSwitch 1, click on next, and basically that's where you specify the labels and stuff like that, and you don't need to check any of these services here, and then click next and you're off and running. Okay, so that takes care of it from the networking side. The key here is that the VM kernels, there are multiple VM kernels here, but each of those VM kernels only is connected to one active physical adapter, and that's how the multipathing of iSCSI is done. So in our case, we are able to do quite a lot of multipathing because we have 2 NICs on our storage array, and we have 4 NICs on our iSCSI host. Let's now switch to storage, and we look at storage adapters. There are 2 storage adapters. I'm sure you know how to instantiate the iSCSI software adapter. You can only have one of these at a time. I've already done that on this host. So when I look at this software adapter, I have these devices. You can see there are 3 devices. If you remember, when we looked at our LUNs, there were 2 LUNs, LUN 1 and LUN 2, each of 200 gig, and a third LUN of 1 gig. And we did create a 4th LUN, but I don't see the 4th LUN here. It is because what we have to do is to rescan. So now the scan is complete, and I have my 10 gig device attached. So now we have the 4, 200, 200, 1, and 10. We can take a very quick look at our storage devices here. So these are the individual devices. They are attached. Click on this one. It gives me all the information that we've seen before when we looked at our storage from the command line. We edited the multipathing and everything else earlier as well. So we saw how all that actually did work. So that's basically it with iSCSI. The multipathing can be changed, as we have seen here with editing multipathing for that device. Right now it's MRU, and there's only one active IO path to it. There's not much you can do there. You can look at the storage adapter. You're familiar with all these other options of scanning for storage and so on. So you have that. The SCSI adapter has all these targets, and there are 18 paths. There are 4 devices. We can look at the paths for that adapter. So this is all those paths. We've looked at runtime names before as well when we were doing the PSA, the pluggable storage architecture, which is essentially your HBA name, channel, target, and your LUNs. And you can see that there are connections to different IP addresses. There are 2 IP addresses basically that we have in place here. 90.1 and 90.2. The iSCSI port, as you know, is 3260. So nothing much here to add to iSCSI. We can go to the command line, take a look at some of the iSCSI namespace possibilities that exist as well. So we are back again in 192.168.0.201. When you enter the command iSCSI and the namespace iSCSI, these are the options that you get. You can look at the adapter, the network portal, physical network portal. This basically is the VM kernel NIC. These are logical constructs from the iSCSI specification that have been converted over and kind of translated over into vSphere. There's not much that one actually wants to do here. We can look at the iSCSI adapter list. I would assume adapter list. And there's just that one adapter with the iSCSI VMK driver and the UID, which we saw before. For iSCSI iSCSI session list, and we have all these sessions which we can pipe to more. So this is what we see when we go up into the storage array as well. You saw the various connections to the various targets, so that's all that is. Really, in my view, in this ESX CLI iSCSI, namespace, there's not much that is required, at least from the software iSCSI perspective. The IBFT boot is interesting because sometimes we need to load the IBFT boot table if we are booting off an iSCSI disk, which I'm not. I'm booting off a local internal disk, but it would be interesting to see what those options are. IBFT boot. We can get the details, and there are no boot tables because we really haven't set up any of this IBFT specification anywhere. Actually, my NICs do support IBFT, but I'm not doing a boot from iSCSI, so it's not relevant to me at this point. The iSCSI plugin, and we can list the iSCSI list. Again, there's not going to be very much there. There's a VMware plugin, and there's a QLogic plugin. Again, not really relevant. iSCSI works very nicely. It's very fast. Multipathing is very easy to set up, as we've seen. We saw how to do the iSCSI configurations both on the host side as well as the array side as well. So having looked extensively at iSCSI and looked at the configuration both on the storage array side in terms of targets and LUNs, as well as on the host side in terms of being able to provide multipathing. We looked at how we need to be sure the VM kernels to be used for iSCSI need to be made compliant, and that's done by having only one active adapter and all the other adapters in unused mode. In the next video, we will look at LUN masking. We'll look at the storage array and the ESXi side as well. I look forward to seeing you there.